Hi, and welcome to the RIP channel. In this video, I'll give you the motivation for RIP, or row integration by parts. As indicated in the introduction to row integration by parts, RIP is the tabular method for integration by parts, with an emphasis on the rows. Each row represents an integral, and we proceed one row at a time. However, what's the motivation? Why would we bother putting the information together like this? Well, the actual motivation for the RIP method is when we iterate integration by parts. That is, suppose we take the formula for integration by parts and we wish to replace the new integral with another iteration of integration by parts. It would give us something like this. If we choose to differentiate f again and integrate g again, this is what the formula would look like. And of course, we could do it again. And then the question is, when do we stop and why? Well, loosely speaking, the blue terms give us the bulk of the antiderivative that we're looking for, and the integral is the remainder. We got to control the remainder before we know if the terms in blue are any good. So in other words, the last integral helps us decide to stop. Then we gather the terms to build the antiderivative. So let's look at what the table will generate when we proceed one row at a time. So again, this is the tabular method for integration by parts, but we proceed one row at a time. The notation we're going to use is fk's to indicate kth derivatives of f, and g negative k's to be kth antiderivatives of g. We start with 4 columns, alternating plus minus signs, functions to be differentiated, functions to be integrated, and when we need it, a 4th column to indicate the integral of the product of the information in a given row. The top row always represents the original integral. One step down gives us the new integral that we obtained from one iteration of integration by parts. If we continue to differentiate f's and find antiderivatives of g, then this is what the table will generate. And again, we take 1 times derivative of f times integral of g, integrate that product, and that's the new integral that we obtained for this iteration of integration by parts. But when do we decide to stop? There's got to be something about this new integral that tells us when to stop. So in the first 2 examples, we were able to evaluate these integrals really easily. However, say in example 3, where one function's an exponential and another one is a trig function, well, it's not as easy. We can't just evaluate this integral, we have to do something else. But for whatever reason, we decide to stop at this level. The next thing is to gather the terms to build the antiderivative for the original integral of f times g. But we just take 1 times f, go down a row, multiply by the integral of g, and then continue like that. -1 times derivative of f times second integral of g, so on and so forth. And the last term always comes from the integral represented in the bottom row. However, we may not always want to proceed this way. If you check out example 4, well, it's a bit more complicated to summarize. However, the idea is that we don't just differentiate all the f's and integrate the g's. We're going to change our mind part of the way through. And that will change the way that we gather the terms just a little bit. Okay, so please subscribe, check out the playlist, and learn to master integration by parts.